Hello everybody, so today I will talk about the calculus. The topic today is about cylindrical coordinates and spherical coordinates in here. So here is about the question and here is about the triple integral that we need to do about cylindrical and spherical. So I will show the answer in this the question. About cylindrical coordinates, first we need to analyze the boundary between x, y, and z in here. So we have the boundary of the z is between the square root 18 minus x power 2 minus y power 2 with the square root x power 2 plus y power 2. In here we have x between the square root 9 minus y power 2 and 0, and y is between 3 and 0. So that's why we have the boundary in here. Later that we put the square in the both sides. That's why we have 18 minus x power 2 minus y power 2 greater or equal to z power 2 greater or equal x power 2 plus y power 2 in here. Similar this one, we put the square in the both sides. That's why we have y minus 9 minus y power 2 greater or equal x power 2 greater or equal 0 in here. So in the number 1, I need to highlight in here. If we put the minus y power 2 on the right, we got about x power 2 plus y power 2 smaller or greater than 9. This one is about the function of the circle, so that we have the radius in here is about 3, because we put the square with number 9, we got about 3 in here. So we can find the boundary of the r. R is about the radius. Radius in here is about between 0 and 3. On the next one, I draw the diagram to illustrate in here. So in this diagram you can see that y is between 3 and 0. So this is from 0 and 3 in here. This is the boundary of the y in this area from 0 to 3. The boundary of the x is between 0 and the square root 9 minus y power 2. If you look carefully, this is about the circle with the square root. So the x, they from 0 to the square root 9 minus y power 2 in the square root, that is under this circle. So if we find the boundary between x and y, you can see that y go to 0 to 3, x go to 0 to the square root of the 9 minus y power 2. So this is about 1/4 of the circle, or we can write about p divided by 2. So we can find the boundary in here, that is from 0 to p divided by 2 in here. That's about 90 degrees in here, and that's why we have the boundary of the theta. So after we put everything, we have x power 2 plus y power 2. That's about the r. So that's why we convert the r in here and transform this one too. That's why we have the square root 18 minus r power 2, 0 to 3. That's about the r is about the radius we just calculated here. And the last one, theta, in this one we have from 0 to p divided by 2, and we apply the formula is about r dr dz and dphi, and we have x plus y power 2 transfer to r power 2 in here like this, and z power 2 we keep the same one. So here is the answer about the cylindrical coordinates. This is the answer. The next one we will use about spherical coordinate. So we use the boundary of the z in here. and we put the square in the both side. We put x power minus x power 2 minus y power 2 to the right. So we have 18 is greater or smaller x power 2, y power 2, and z power 2. So if you look carefully, that is similar x power 2 plus y power 2 plus z power 2 equal to rho power 2. So that's why we have rho power 2 in here. It's about 18, and we put the square root in the both side, and we got about square root 18. Now we have this formula from here, and we have x power 2 plus y power 2 equal to z. That's it in this one, because z power 2 greater or equal to x power 2 plus y power 2. So that's why we convert this one to about the z power 2. That's why we have 2z power 2. Then we find z equal to 3, because we have z and rho in here. So we apply the formula from spherical coordinate is about z equal to rho multiplied with cosine theta. So we have z is about 3, rho is about square root 18, and we calculate in here to find the phi. So, and the phi in here is about p divided by 4. After we calculate rho, theta, and phi, we have rho is about square root 18 from here. Theta is about p divided by 2. That's it. About this one we just explain the circle in the diagram, and the theta is about between 0 and p divided by 4. Later that we have the formula to apply in here. This is about the function, and dv is about rho power 2 multiplied with sine theta, d theta, and d phi. So this is about the function we put in here. This is about x power 2 plus y power 2 plus z power 2. And in the spherical coordinate, we convert s is about rho sine phi cosine theta, y is equal to rho sine phi sine theta, and the z is about rho multiplied with cosine theta or cosine phi in here. Later that we do the factor in here. We have sine, and we have cosine and sine here. We put them in the same group, and we see that cosine power 2 plus sine power 2 equal to 1. So that's why we got about sine power 2 phi and cosine power 2 phi in here. We put rho power 2 outside. That's why we have rho power 2 and rho power 2 in here. This one they will become number 1, and rho power 2 multiplied with rho power 2, and you got about rho power 4 in here. And here is the answer for the question about spherical coordinate. That's it, the end. Thank you for watching.